Today we are going to learn together how to plot data and graphic functions in MATLAB or Octave, and I'm just going to follow the MATLAB primer provided by MathWorks because it's a very good resource. It's in chapter 4 and this is all about graphics. You can also follow this, so let's get started. Okay, run Octave. Okay, the basic plotting is very simple. All you have to do is prepare your data. Just the X is necessary, is mandatory. Okay, so you can see the variables there. Only the Y values are necessary. So you can put a linear values here. Let's try. Okay, and I can just plot that one. Let's try that again. Oops, let's use, I meant to say square. What's square? What's the square? Okay. There's definitely a square function here. Oh, why do I have to use a square? This is enough. Oops. Let's use the square. And I'm gonna plot that one with a line width of 3. Okay, that's the square plot. And we can also do a scatter of this plot. I'll use hold on so that we to use the scatter you have to have the X vector also. So I want to use the plot again, but this time I'm going to plot using a green circles. Okay, those are the data lines, the data circles, and also the line plot of this simple square function without having any x's. So the x is automatically inferred from the column indexes from 1 to 21 in this case. But we can also use the x values. Say we go from 0 to pi divided by 100 and then to pi. That's the x values, and the y values are the sinus. And then we can plot this. I'll hold up so we can, or just create another figure. And then we can plot this one, x by y, and I'd like this to have a bigger width. And this is the sinus plot. Using the same technique as before, we can also put the circles in by, hold on, and then I'm gonna plot this again using the green circles with a line width of 3. Okay, so but those are a lot of circles, data points. Another way to do this, if you don't want to make a Y vector or array, we can also use a function. So I'll create another figure now, and I'm gonna put a Y function instead, and then put add here, and make the function has a x parameter, and then put sinus x as the definition of the function. Now we can plot this same as before, but now we are using not the data of the y values, but only the function. This function will then be applied to all the x values. So, okay, I think I should put an add in here. No, let me check. It should be able to x and y. So it doesn't support a function. Let me try again. Okay, this should work. Okay, so I guess it's a different function. It's using fplot instead. So let's try that one. So we should do fplot for the y function, and then the x here. Maybe put at here. Working. Okay, so it's just the limits, not the x values. So that means instead of x, I will put -10 to 10 instead. Oh no. Yeah. -10 and 10. Sorry. Fplot. Where's the error? This must appear followed by a value. Let's try removing this. This work. Okay. That works. I think it means that I have to put the type of plot first. And then the line width of 3. No. That's weird. Where's the style? Line spec. This is where this should work. This should work. Maybe it's case sensitive. Nope. It's really weird. Okay, let's try again. Plot line width. Okay, this is quite complex. Let's use easy plot then. Who knows, this might work. Let's hope so. And going to easy plot first. Should work. Okay, that's the plot from easy plot. Now what I want to do is set the color of that. Oh, I have to make it. And set H to color into red, and then the line width to 3. Let's hope that works. Okay, that works. This is rather complicated way. I don't know why MATLAB or Octave don't just allow line styles there, but at least you can use EasyPlot to plot using a function, using a function handle. Now to make your plot more interesting or more clear, you can put labels in the x-axis using x label. And so the x label is changed. And you can also put the label on the y-axis, sign of x, and title for the plot. Plot of sign function. And I'm gonna put font size 20 there. I think the x label is also here if we have a big font size. And the y label 14. Okay, I hope you can see that. Now we can also plot multiple data sets. I'm gonna try creating a z function where it's the cos of x, maybe divided by 2. And then the z would be the z function applied to x. And then I'm going to plot, create a new figure. I'm going to plot by x the y, and by x again the z data, and as always I'm gonna use line width 3. Okay, so the line style only applies for the last for the second data set, so I'm gonna put line width 3 also for this one. Okay, this is the plot of a sine function and the cosine function of x divided by 2. Now let's find out if EasyPlot can do this also. I'm gonna try to plot the y function and the z function from let's say 0 to 7, just to make it the same as the current graph. Okay, Well, I guess this is not what's intended. Let's find out what EasyPlot actually means. I guess it cannot do that. Okay, it's only one, so I have to use EasyPlot. Then I need to first plot the first function, and then set the line width 3, and then I'm holding on, and I'm going to create yet another EasyPlot with the Z function from 0 to 7, and then set the color to green and line width to 3 also. And that's how you do it using EasyPlot. And as always, you can set the legend. You can set the title, of cosine and cos, font size 20, then the X label is 0 to 7, font size 16, then the Y label Y, and Z using font size of 16. Now, as I mentioned before, you can also put a legend in there. So the first is X equal to sine of Y equals to sine of X, and the second line is the Z, which is equal to X cosine of X divided by 2. And then that's the legend. I'm gonna increase the font size. Okay, cannot put the font size there. Why? Oh, I think I just you need to do this separately. No, that's not possible. Okay, so actually we have to save this first into the handle of the legend, and afterwards we can set from the handle of the legend font size to 18. This should work. Okay, that's how you plot two lines, two functions using EasyPlot, and then set the color, the line width, and set the legend for each. I think I should be able to set the line width too of the legend. Let's make it 5. Okay, that's not the right property to set. So let's find out what is the real property for this one. Okay, that's weird. Let me try looking at the properties. Okay, I give up on this one because I don't think it's in my or your interest to deep dive into properties of a legend handle just to be able to change the lines within the legend. I wonder why MATLAB or Octave don't make this easier to change. I'm pretty sure that we can do this easier in R. Alright, let's go back to basics and just plot the simple plot. Now there are different kinds of colors and line styles and marker type that you can see in the MATLAB primer and also the MATLAB documentation. So let's try each one of them. So let's use a yellow circle. Okay, that's okay. Let me create a new figure. All right. Just using a yellow circle. Okay. Use a line width 3 again, so you can see it. And we can also use the plus mark. Maybe change it to magenta. And okay, hold off. I think it's already hold off. Let's try using asterisk or and maybe the line width is too big. Let's try just 2 or 1. Okay, and you can also use a triangle and so on and so on. Okay, and it also appears that we can create both a line and a marker. So let's try. Okay, that's a line and a marker. You can really see the marker. Maybe try can I have a different color? It's not really visible here. I guess the color of both the line and the marker must be the same. Yep. So just to make it a little bit easier to visualize, I'm gonna create only the first 10. Okay, so there you go, a line and the markers. Let's see, let's try again. Does that work? Nope, doesn't work. So the line and the marker must be the same. If you want it different, then you need to have 2 different plots. Or you can use the same plot function, but make it x1 to 10 and then y 1 to 10, and then replot it again using a different style. Now the blue line, and then we will use a red triangle pointing left, line width 2. And that's how we do that. Now you can also plot imaginary and data with complex numbers. Okay, let t be from 0 to pi divided by 10 to 2 times pi, and then the data would be the exponent of the I imaginary number times t, and that's the w. So we're going to plot the w using a line and circles. So okay, and to make this plot more circular, we can use axis equal. So in this case, the y-axis is the real part, and the x-axis is the imaginary part. Okay, so now let's try to do a surface plot using x function, and then plot this. Okay, that's cool. And remove the lines. Okay, now I have used hold on before, so basically hold on means that rather than replacing the entire figure like this, what hold on does is after we plot, and then we use hold on, then add a contour, then it just adds the contour graph on top of the previous graph. Okay, let's try to create a new figure, and we can also use multiple subplots in one figure by doing, let's make this again from 0 to 2 pi, and then we'll make an area using 3 rows and 1 column of a subplot, and then we want to plot the first subplot first using sine of x. And after that, if you want to make a subplot, I think in horizontal, I think it's better if you use 3 columns instead. I want to plot the sine of x, the line width 2 or 3 is fine. And then I'm going to have another subplot. For the second one, you plot the cosine of x, and then we use another subplot to plot the sinus times the cosines. Now let's play with axes. Make a new plot again. We can change the axis by doing axis and the limits from the maybe like 0.1 of the x, and the maximum is say pi, and then the minimum y maybe half minus half, and then let's say 1. Okay, so by doing this we can choose which part of data that we want to plot, and we can return it back to auto. We can also make it square, aspect ratio, or make those axes the same length. Or you can make it back to auto or auto normal. You can turn an axis off, and you can also make the grid on or off. Where's the grid? There you are. So I guess the grid requires the axis to be on as well. So we can also put a text somewhere. Let's say I want to put the text at this point, maybe half and -1. So there will be, and then the text, it's a sign. It's a sign. And get the font size 20. Okay. Okay, so the axis is turning itself. Okay, so the axis changes. Let's put the text somewhere else then. Should be -half. Okay. Here's what I'd like to do is plot it and then use that text. Okay, that's much better. And grid on. You can also save a figure using save fig. Well, this is not supported in Octave. Okay. But we can still use save as. So save as figure 7 to say and it's a sign .png. Okay, that works. And this is a figure that you can include in a document or post to a website or whatever. Okay, now let's move on to mesh and surface plots in the MATLAB primer. It's in page 419. Okay. Now to do this, we first need to create a mesh grid. These are the axes in two-dimensional world. And Let's make a function y squared plus epsilon, and then calculate the z values. Then let's draw the mesh. Okay. Now the mesh grid is the x and y is in here. It's the bottom axis. It's not actually the bottom, it's a plane. And the z values are up here. So it plots from this x and y, this area, given the z. Let's see if a mesh grid is able to create a rectangular instead of a square area. So yeah, all I have to do is put how much x I want and how much y I want. So let's try doing it again. This time I'm gonna create a mesh grid where the x is just like before, and where the y is, I don't know, maybe from 0 to 16. And let's calculate the r again. And let's calculate the z again. And let's plot it again. Okay. So this is the x is still the same. This is the x-axis, still the same, and the y-axis spans from 0 to 16, and then we plot the z here. And again, we can save this very nice figure using save as. I think it looks like horn. Cool. Again, we can vary the shading. For example, I want to use a interrupt shading, or let's see what kinds of shadings is possible. We can have a flat one, we can have a faceted, and we can have a interrupt just like before. We can also make it transparent by using a color map and alpha. Oh. Okay, this is not working in Octave, but if you are using MATLAB, then it will work. Okay, let's see what color maps are there. Color map list. Okay. Let's try color map black. Okay. And color map winter. Color map summer. Color map rainbow. Color map prism. And so on. Now let's try using a camera light for lighting. Well, it's also not implemented in Octave. Lighting font, not implemented. Now we can also display a matrix or numeric arrays as an image. Now let's try this. I'm gonna generate magic square by, let's say, 400, and then display this using imshow on this. Okay. Let's try using. Let's see what is about. 1 to 50, I guess. Okay, I think the values are too much. The values of each one in the matrix must be between 1 and 128. So let's divide each element of this matrix by 2000. Okay, I can just use this. How do I do an integral divide? Okay, so it's a separate function. Okay. I divide 0 by 2000. And let's show that again. Okay. Let's try to use a different color map. Okay, now this is the HSV. Maybe try rainbow or prism. I think I'd like to use remainder instead. Okay, let's try that again. Magic of 400, and then Dürer divided by 1000. Okay, remainder plus 1, and then show it again. Nothing. It should be good. Rainbow, HSV, flag. Let's test that. Let's try different. Okay, so the color map is from 1 to 128. Should be, but it's not, so, or maybe it has to be double. Let's try again. Divided by 28, and okay. So I guess it actually should be between 0 and 1. So let me try that again. So magic 400. And divide it by 200,000, and then let me plot that again. Okay, now this is more like it. I can have a different color map like prism. Okay, and flag or summer or winter. Now let's try having a random random image. Let's see. A two-dimensional one. Random of 400 by 400. And let's plot this one. Okay, so here's the image of a random distribution, and let's try another one for, oh, this is for the uniform distribution, and try again the random image of a normal distribution. Okay, try a different color map. That's more colorful. And you can save this image using imwrite. So let's just do this again. It's a random n thing. Okay. Oh, sorry. I have to put the variable first, which is the random image. Okay, 8 bits per pixel. Why? Let's write n. It's not the same. 8 bits per pixel. Why? My version of graphics magic. This is weird, but that's okay. Maybe I'll try using a different file format. Let's try JPEG instead. Hope that's better. That's actually worse. Maybe what it wants is actually the result of the im show. Oh, we have a map here. So writing, and then we need a map here. So the map would be summer. Yeah. Maybe color map summer. Okay. That's not working. Okay, still wonder why this is not working the way it's intended. Let's try EMP. Okay, this is getting weird. And let's try TIFF. Alright. I want to know why this is happening. Okay. Should be that simple. Summer using JPEG. Nope. Using PNG. Nope. Okay, this is getting very weird. Using TIFF. This should be working. Alright, let's just move on. Okay, so I just found out that you can actually set the properties of a plot by just setting not using set, but using the handle dot something, maybe like line width 3. This would work in the MATLAB 2015, but in Octave this is cannot be done. Yeah. So basically, in Octave or older versions of MATLAB, then you need to use this. This will always work. It's not very convenient, but it works. Okay, that sums up our tutorial for this session. And in the primer, you can see there are ways to manipulate the handles and properties of objects in the figure or a plot, but I'm not really fancy in doing that. So thank you for joining, and I hope you enjoy the session.